Hey guys, welcome back in. Mr. Marone here. Welcome to Chapter 9. This is a quick chapter we're going to be in for just a little bit. There's only 2 sections in this chapter, and it's all about coordinate geometry. In other words, we're going to take figures we've already looked at and also figures we haven't looked at and put them into the coordinate plane and start to figure out what we can do with them. This first section where we just focus on polygons is going to bring back 3 things we've used in the past and you should be comfortable with. And now we're going to apply them to the idea of polygons. So if I'm looking at this given triangle that I have here, all in the first quadrant, so everything's positive, they want to know some different properties about this figure. So the first thing they want to know is what's the length of AB? And we do that using the distance formula. So the distance formula is this big square root of the difference in our x values squared plus the difference in our y values squared. In other words, it's Pythagorean theorem. So if I wanted to, I could draw in a little right triangle here, and I know that the distance of my one leg is 1, 2, 3, 4, 5, and I know the distance of my other leg is 2. So in here, if I'm looking for AB, in here the difference in x from A down to B is 2 units. And the difference in Y is going to be 5 units. So figuring all this out, 2 squared is 4, 5 squared is 25. I get that AB is equal to the square root of 29, which we cannot simplify. We're just going to leave it just like that. Alright, so distance formula is really easy to work with. When you've got a graph, you can just draw in a right triangle and find Pythagorean theorem, which is wonderful. Now, the second piece of this, the second tool that we have that we can help answer questions is finding the middle of a segment. We talked about it called midpoint. So they want to know what point bisects AB. And my midpoint formula is that I'm going to average the 2 x values. So I'm going to do x1 plus x2, and I'm going to divide it by 2. And I'm going to do the same thing for y. I'm going to do y1 plus y2, and I'm going to divide that by 2. So what we had there is really the average. Notice if it's midpoint, that means I need an x and a y coordinate. I shouldn't just get a single number for this. So if I want to know what point bisects AB, well, my 2 x values are 1 and 3. So I'm going to do 1 plus 3, and then I'm going to divide that by 2. And my 2 y values are 1 and 6. So I'm going to do 1 plus 6 divided by 2. And that gives me 4 over 2. And 7 over 2, which really simplifies down to 2 and 3.5. So that right there, if I go to 2 and then up to about 3.5, right there is the midpoint of AB, the point that bisects AB. So we've got distance as one tool, we've got midpoint as another tool, and then the final thing that we can use, distance can be used to figure out whether or not figures are congruent or side lengths are the same thing. Midpoint we can use to find the middle of something, and then our last tool is if I want to know whether figures are perpendicular to each other or lines are perpendicular to each other or whether they're parallel to each other, I can use slope. So they want to know, why do slopes of AB and BC show that the angle is 90 degrees? Well, if we have perpendicular slopes, perpendicular is going to give me that their slopes equal -1 when they're multiplied together. And if I've got parallel, that tells me that they are the same slope. So I've got these tools that I can use. And remember, our slope formula is y2 minus y1 over x2 minus x1. So if I'm looking at AB, my difference, if I'm using this as, this can be x1, y1, and then this one can be x2, y2. So if I'm doing my math here, the slope of AB is going to be y2, 1, minus y1, 6, over x2, 3, minus x1, which is 1. So 1 minus 6 is going to be a -5, and 3 minus 1 is going to give me 2. So that's my slope of AB. If I look at BC, we'll keep x2, y2 there, so we'll make this one x1, y1. My slope is from 1 minus 3 over 3 minus 8, which is going to give me a negative 2 over a negative 5, or 2/5. So if I look at negative 5 halves and 2/5, they together, if I were to multiply them, negative 5 over 2 times 2 over 5, that gives me a negative 10 over 10, which is negative 1. So they are perpendicular slopes. That tells me that the angle at point B, that shared point, is going to be 90 degrees. So you've got three tools here. You've got distance, anytime you're trying to find congruence. You've got slope, anytime you're trying to find perpendicular or 90 degrees. And then you've got your midpoint. Let's take a look at some examples. Oops, they're right here. Let's take a look at this first example. So it says, given triangle ABC on the right, it's the same triangle we were just working with. They want to know what is the length of the segment connecting AC and BC, and they're the midpoints. So they want to know what is this mid-segment's length. So we have two things we need to do here. First, we need to figure out what those coordinates are. So we need to find the midpoints. So midpoint of AC and BC. And then the second thing we're going to need to do is distance of my new figure there. So the midpoint of AC is going to be 1 plus 8 divided by 2, and 6 plus 3 divided by 2. And that's going to give me 9 over 2 and 9 over 2, so 4.5, 4.5. So that's 4.5 comma 4.5. All right. And then for BC, I've got 3 plus 8 over 2, and I've got 1 plus 3 over 2. So that gives me 11 over 2, or 5.5, and 4 over 2, which is 2. So that gives me, this point is 5.5 comma 2. So that was step 1. Now step 2 is going to be the distance. So my distance there is going to be the difference in x. So it started at 4.5 and it went to 5.5, which is 1 squared. And then it went from 2 to 4.5 vertically, so that went up by 2.5 squared. So I've got 1 squared is just 1, and then I've got to do 2.5 squared, which is 6.25, and when I add those together I get the square root of 7.25, which, since we've already got a decimal underneath, we're going to do the square root of that. And finding the square root of 12.5 gives me roughly 3.54 for my distance. So in order to tell what that distance was, we first had to find the midpoint and then do the distance. So these are a little bit tedious problems, and you really have to ask yourself, what are they asking? Okay, we're going to take a look at one more of these. And in this case, they've given us a parallelogram RSTU, and they want us to tell them what type of parallelogram it is. And if we think back to our work in chapter 6, we had our little Venn diagram, and we had parallelograms, and inside of there we had the rhombus, and we had the rectangle, and then inside of there was the square. So we had to have a rhombus and a rectangle for a square. And with a rhombus, that rhombus was 4 congruent sides. And with a rectangle, we had 4 right angles. So in order for us to be more specific than just a parallelogram, we need one of these two things to be true. In order for us to tell this, if I'm looking for congruent sides, I need to do distance. Looking at our picture, we can tell that they're not going to be 4 congruent sides, but mathematically we do have to show it. The nice part is, as soon as you don't have congruence, as long as you find two distances that aren't the same, you can stop. So in other words, if I do the distance of RS, looking at this, it goes up by 3 and over 1. So I've got 1 squared plus 3 squared. And if I set up ST, that's going to give me square root of 10 there. And if I set up ST, the distance there is 1, 2, 3, 4, 5, 6 squared plus 1, 2, 3, 4 squared. So that's 36 plus 16, or square root of 52. So just by doing that little bit of math, we know it cannot be a rhombus. That's out. Now we have to check if we can do 4 right angles. If we find at any point we don't have perpendicular angles, we can stop. So I'm going to use those same 2 sides. I'm going to use the side of RS and the side of ST and find the slopes of each of those to try to see if this is a 90-degree angle. If it is, we have to move on. If it isn't, we can stop right there. So my slope of RS is 8 minus 5 over 2 minus 1. That's going to give me 3 over 1. So my slope there is 3. For ST, my slope is 8 minus 4 over 2 minus negative 8. Or 2 minus 8, sorry. So 8 minus 4 is 4, and 2 minus 8 is negative 6, which simplifies to 2 over negative 3. These together do not equal negative 1, so we can't say that they're right angles. So this figure is just a parallelogram. I know I kind of motored through that, but I wanted to make sure that I went back and talked about it. So with a rhombus, we needed 4 congruent sides. By doing the distance formula for RS and for ST, we showed mathematically they are not the same, so we can't have a rhombus there. In order to do a rectangle, we needed, before we'd even do that, as soon as we don't have a rhombus, we can't have a square. You can't have a square without a rhombus. So that eliminated that one. And if I have my 4 right angles, then I have a rectangle, but we just showed by looking at this angle alone that it's not a right angle. So if that one's not a right angle, we don't have 4 right angles. Therefore, we cannot say it's a rectangle, and it has to be just a parallelogram. This last piece in your notes is so awesome. This is one collection of all 3 formulas and an example of each one. So you've got your distance formula, you've got your slope, and you've got your midpoint, and it really does a good job of describing what each one does. I would reference this as often as possible when I get stuck. Hopefully that gives you a good feeling for 9-1. Bring in any questions you might have as we progress, and I'll be able to answer them then. Have a great night, guys. Bye-bye.